Hi there, we're going to have a look at equations involving fractions, and this time we're going to have to look at fractions which have different denominators, numerical denominators. We'll get onto that in a minute. Just want to cover a couple of prerequisites, things that we're going to use as we do this type of equation. The first thing is to remember about lowest common multiples. I'm sure you probably remember doing stuff like that before. We're looking for numbers which appear, in this first case, in the 2 and the 5 times table. Common multiples are numbers that appear in the multiplication tables of both 2 and 5. So, of course, you've got 2, 4, 6, 8, 10, 12, and so on at the 2 times table. 5 times table, 5, 10, 15, 20, and so on. So the lowest common multiple of 2 and 5 is the first number that appears in both lists, which of course is 10. So the lowest common multiple of 2 and 5, we can say, the LCM, lowest common multiple, equals 10. For 20 and 4, well, it's 20 times table, the 4 times table. One of the ways you can look at it, of course, is that one number might be a multiple of the other. So we're not always looking for a number that's bigger than 20 and 4. Sometimes it might be the bigger of the two numbers, and of course 4, if you think about the 4 times table, 20 is in it. So the lowest common multiple of 20 and 4 is actually 20. So we could say that 40 or 80 are common multiples, that's for sure, but we're looking for the lowest one, the first one in each case, and that's important. When you've got three numbers like 3, 4, and 10, different strategies that you can use. One of them is to find the lowest common multiple of the two smaller ones. So in this case, 3 and 4, lowest common multiple would be 12. And then you're just thinking, what's the lowest common multiple of 12 and 10? 12, 24, 36, 48, 60. Well, 60 is the first number that ends in a 0, so the lowest common multiple in this case would be 60. The other way is actually to find the lowest common multiple of the largest ones. So 4 and 10, the lowest common multiple is 20, and your other number is still 3. And again, you're just trying to find, going up the 20 times table, 20, no, it's not divisible by 3, 40, no, 60, yeah. So there's different ways when there's three numbers, but if in doubt, write out some multiplication tables. Second prerequisite is solving equations with brackets. Again, hopefully you've come across that. Just wanted to remind you of a couple of things. In this first one here, we're going to multiply the first bracket out by 3. 3 lots of x plus 1 is 3x, and then 3 times 1 is plus 3. So it's important to multiply that out. Second multiplication, plus 5 lots of 2x minus 3. So we're going to multiply 5 by 2x, and remember that's positive 5 times positive 2x is going to give me a plus 10x. Plus 10x. And remember to keep multiplying. Positive 5 times negative 3 is negative 15. Positive times negative, watch these signs. The right hand side is 40. I can simplify the left hand side. I can gather together my x terms, just be careful. Positive 3x plus 10x, they're both positive. Positive 3x, positive 10x is 13x. I can do the same with my number terms. What have I got? I've got positive 3 and I've got negative 15. So 3 subtract 15 is negative 12. So I got negative 12 equals 40. Then I can solve this basic linear equation. 13x minus 12 equals 40. I can get rid of the minus 12 by adding 12 to both sides. Can balance that up, which gives me 13x is equal to 52. And then I can divide both sides by 13. And fortunately, 52 divided by 13 is 4. We can see that x equals 4 is our solution. We can always check. Substituting 4 into the first bracket gives us a number 5. So we would have 3 times 5 plus 5 multiplied by 2x minus 3. 2 4s are 8, minus 3 is 5. So we've got 3 5s are 15, plus 25 is 40. So the equation holds for x equals 4. And the second one, I just wanted to make the point with the negative multiplier here. So be careful, multiply it out, 8x plus 4. You've got negative 3 times x is negative 3x. And of course, negative 3 times negative 2 is positive 6. And then we finish it off in the same way. 8x minus 3x is 5x. Positive 4 and plus 6 is plus 10. And then we've got subtract 10 from both sides. 5x equals 35. Divide each side by 5. X equals 7. And if we substitute in, we can see that actually that's correct. So that's just a wee bit of prerequisites. We can go on now and check out what the first example is. So what we're going to have equations like this. To solve equations with two or more fractions with different denominators, we're going to multiply both sides by the lowest common multiple of these denominators. Effectively, we want to make those fractions disappear. We know that we can, if we multiplied the first fraction by 2, then the divide by 2 would cancel out, but it wouldn't make the second denominator cancel out. Similarly, multiplying everything by 3 wouldn't, but that's why we have to then think of, well, what multiple of 2 and 3 is a common multiple, which is 6. So what we're going to do to first of all solve this is we're going to multiply both sides by 6. Okay, now notice that unlike before, that's not going to get rid of both of the numbers. They're not the same, so dividing by 2 and multiplying by 6 will not score out both of them. We normally end up multiplying by the same number in our denominator, so we can't do that. We have to be careful. That in actual fact, we say 6 divided by 2. Think about 6 divided by 2 is 3. So what I'm going to be left with is a multiplier of 3 in front of that first bracket. Okay, another way of thinking about it, if I maybe did this, get rid of that, and we'll do this. I'm multiplying both sides by 6. So effectively, what I'm doing is I'm doing that. I'm multiplying everything by 6 on both sides. So you can see that really, if we do multiplying by 6 and dividing by 2 overall, cancels out to just multiplying by 3. And that's why I've written the 3 here. What about the second fraction? Well, we've got multiplying by 6, but dividing by 3 overall is just going to be the same as multiplying by 2. So what I've got here is I'm going to have a 2 as my multiplier on the second expression. And don't forget, on the right hand side, 6 times 6 is 36. So see what's happened here. I've multiplied both sides by the lowest common multiple of 2 and 3, which is 6. And it's got rid of the fractions, which is good, but it's also introduced a new multiplier in front of both of the terms. And that's why we need to do the prerequisites of then going from here. So I'm going to quickly say multiply the first bracket by 3, multiply the second bracket by 2, and then simplify. So that hopefully this bit's familiar enough. It's the first part. 5x plus 20 equals 36. Take away 22 from both sides. We end up with 5x equals, what's that, 14. Okay, and oh, yeah, no, I'm just going to check. I thought it would work out slightly differently, but so we end up with, what have we got, 5, divide through by 5, doesn't work out as an exact value, x equals 14 over 5, or 5 goes into 14 2 times, remainder 4, so you've got 2 4/5. Okay, so there's the answer to that example. Let's have a look at the next one, see what we can do here. So we've got x minus 1 over 3 plus x plus 2 over 9 equals 3. So we want to think about the lowest common multiple of 3 and 9. So that happens to be with 3 and 9, 3, 6, 9, and then 9 is just there. 9 is the lowest common multiple of both. So we need to multiply both sides by 9. Or you can think about doing that. And that's probably quite a good idea because it already introduces the brackets that we're going to have to probably keep in there. So if you put a 9 in front of both of them, you can see that 9 divided by 3 is 3, and 9 divided by 9 is 1. So I can simplify that by saying I've got 3 lots of x minus 1 and plus 1 lot of x plus 2. And remember, 3 times 9 is 27. It's easy to forget to multiply the other side by 9 as well. So we've got multiply out 3x minus 3 and plus x plus 2 equals 27. 3x plus 1x is 4x. Negative 3, watch this, negative 3, add 2 is negative 1. And that gives me 28. Add 1 to both sides. Oh, hang on. I don't know why I was already ahead of myself. It's not 28, of course. I was already thinking of adding 1. Okay, so I've got 27 here. With negative 3 plus 2 is negative 1 equals 27. Then we're going to add 1 to both sides. We get 4x equals 28. Divide both sides by 4. 4 7s are 28. Therefore, we can say that x has the value of 7. And if you want to try and substitute that in, 7 take away 1 is 6, divided by 3 is 2. 7 plus 2 is 9, divided by 9 is 1, and 2 plus 1 is 3. Okay, I think I've got one more example. This time there's a bit of more coefficients on the in the right hand on the top line. So we've got dividing by 2, dividing by 7. The lowest common multiple there is 14. So we're going to multiply by 14. And remember, what we can do is we can just do that. 14 lots of each of them. And then we'll have a look at what happens. 14 divided by 2 is 7. So the fraction disappears. And I've got a multiplier of 7. This one here, 7 and 14, leaves us with 2 as a multiplier. And watch this, it's actually negative 2. Watch this minus sign. So when we rewrite it, it's going to say 7 lots of 3x minus 4 minus 2 lots of x plus 2 equals negative 5 times 14 is negative 70. Multiply everything out, taking great care with signs. Now here we've got a negative one here. Negative 2 times x is negative 2x. Negative 2 times 2 is negative 4. And we've got that. Let's try and tidy this up. 21x take away 2x is 19x. And negative 28 take away another 4. What's that? Negative 32 is equal to negative 70. I want to add 32 on to both of these, which gives me 19x is equal to, well, negative 70 add 30 would be negative 40. And if I add 2 onto that, it gives me negative 38. And if I divide both sides by 19, 38 divided by 19 is 2. Negative divided by a positive is negative. And so my answer is negative 2. Okay, so I hope that kind of makes sense. It helps a wee bit as far as going forward with these types of questions. Go and practice it and let me know if you get any questions.